Good morning everyone. This is mathematics class of grade 8 and this is my lecture number 1 of chapter number 13, direct and inverse proportions. Today we are going to start chapter number 13, direct and inverse proportions. Basically, this chapter deals with two main topics. First is direct proportion and second is inverse proportion. In this chapter, we shall learn what do you mean by direct proportion and what is the meaning of inverse proportion, and we shall learn about variation, its types and uses of variations in day-to-day life situations. So, dear children, you must have learnt in your previous class how to solve a real life simple problem by using unitary method. While solving the problems by unitary method, you must have noticed that increase or decrease, that is a variation in one quantity, causes the decrease or increase, which is again a variation in another quantity. Now, in this chapter, we shall learn about variation, its types, and uses of variations in day-to-day life situations. In this lecture 1, we shall learn about direct proportion. To understand direct proportion, let us take few examples. The first example I have written is, Anuj prepares tea for himself and his sister. He uses 300 ml of water, 2 spoons of sugar, 1 spoon of tea leaves and 50 ml of milk. How much quantity of each item will he need if he has to make tea for 5 persons? And dear children, it is quite obvious that if I need to make the tea for more number of persons, I need to increase these quantities of water, spoons of sugar, spoon of tea leaves and milk also. So this is a case of variation. It means increase or decrease in one quantity affects or causes the increase or decrease in other quantity. Let us consider second example. If two students take 20 minutes to arrange chairs for an assembly, then how much time would 5 students take to do the same job? So, we come across many such situations in our day-to-day life where we need to see variation in one quantity, bringing in variation in the other quantity. For example, if the number of articles purchased increases, the total cost also increases. It is quite obvious, if I need to buy more articles, I need to pay more for that. More the money deposited in a bank, more is the interest earned. As the speed of a vehicle increases, the time taken to cover the same distance decreases. Obviously, if the speed of the vehicle gets increased, we will be able to reach our destination in less time. So, you must have observed in these examples that change in one quantity leads to change in the other quantity. So, if the value of two objects depends upon each other in such a way that increase or decrease in the value of one object affects the value of the another object, then these two quantities are said to be in variation. So, what do you mean by variation? If the value of two objects depends upon each other in such a way that if I am increasing or decreasing the value of one object and this increase or decrease affects the value of another object, then these two quantities are said to be in variation. So, two quantities are said to be in variation if any increase or decrease in one quantity causes the increase or decrease in the other quantity. Likewise, I told you the example that if I need to prepare the tea for more number of persons, I need to increase the quantity of water, I need to take more sugar, more spoons of tea leaves and more milk will be required. So this is a case. This is how we can define the variation. So let us talk about direct variation or direct proportion. If the value of a variable x always increases or decreases with the respective increase or decrease in the value of the variable y. Suppose I have two variables x and y. If the value of x, if I am increasing the value of x, the value of y also increases, that is a case of direct proportion. For example, if I need to buy more articles, I need to pay more. That is, more articles, more cost. So there can be a case where x is decreasing and which results in the decrease in variable y. That is also a case of direct proportion. It means if I am increasing one quantity, there is an increase in another quantity, or if I am decreasing one quantity, there is a decrease in the other quantity. This is a case of direct proportion or direct variation. Direct proportion, as the name indicates, they are directly related to one another. If one is increasing, other quantity will also increase. Like I gave you the example, more articles, more cost. If I need to buy more articles, I need to pay more. If I need to buy less articles, I need to pay less. For example, in the table below, I will be showing one table. We have variable y, that is cost in rupees, which is always increasing when there is increase in the variable x, that is weight of the sugar in kg. Likewise, if the weight of the sugar is reduced, the cost would also reduce. Hence, the two variables are in direct proportion. If you look at this table, you will find that as I am increasing the weight of sugar, like if I am increasing the weight of sugar in kgs, like firstly it was 1 kg, then 3 kg, 5, 6, 8, and likewise, the cost of sugar will also keep on increasing. It is quite obvious, if I need to buy more sugar, I need to pay more. So likewise, if the weight of the sugar is reduced, the cost would also reduced. Hence, the two variables are in direct proportion, because increase in the weight of sugar results in the increase in the cost of sugar, and decrease in the weight of sugar results in the less cost. So these are the variables which are in direct proportion. We find that as the value of x increases, value of y also increases in such a way that ratio x by y does not change. Let us have a look on that table again. If you find the ratio of every number, like first ratio is 1 over 18, next is 3 over 54. If you divide it, or if you take its ratio, you will get 1 over 18. And 5 over 90, if you take its ratio, you will be getting 1 over 18. So likewise, this ratio, this is x, weight of sugar is given by x, this is y. So if I am taking the ratio of x over y, that is always constant, which is equal to k. So this ratio is 1 over 18, which is constant. So we find that as the value of x increases, value of y also increases. It means they are in direct proportion in such a way that ratio x over y does not change. As we have seen in the previous table, if I will take their ratio, it will remain constant. So x over y is equal to k, that is a constant. In this example, 1 over 18 is equal to 3 over 54, where 1 and 3 represent the weight of the sugar, that is x, I told you, and 18 and 54 represent the cost, that is the another variable, that is y. So when x and y are in direct proportion, we can write x1 over y1 is equal to x2 over y2. This is the main concept or the formula which we are supposed to use in the question when x and y are in direct proportion, where y1, y2 are the values of y corresponding to the values of x1, x2 of the variable x respectively. So when two variables x and y are in direct proportion, we need to write, or we can write, x1 over y1 is equal to x2 over y2. As we have seen in the previous example, As if the weight of sugar will keep on increasing, cost will also keep on increasing. And when after taking their ratio, we found that x over y does not change. So x over y is constant. That is why it can be written in this manner, that x1 over y1 is equal to x2 over y2. Now let us talk about the homework part from NCERT. Dear children, you are supposed to complete question number 1 to 10 of exercise 13.1 in your homework notebook, and I will be discussing 1 to 5 question of the same exercise here in this lecture. So you are supposed to complete 1 to 10 questions of exercise 13.1 in homework notebook. In this lecture, I will be discussing question number 1 to question number 5. Rest questions you are supposed to do on your own. Once you will get an idea, you will be able to solve the questions. So, in this lecture, what we have learnt? We have learnt about direct proportion. Basically, two quantities are said to vary directly if the increase or decrease in one quantity causes the increase or decrease in the other quantity. Like, the cost of articles varies directly to the number of articles. More articles, more cost. Less articles, less cost. The work done varies directly to the working time. More work done in more time. Less work will be done in less time. So these are the examples which you can relate to get an idea about direct proportion. So let us talk about NCERT questions of exercise 13.1. I will be explaining question number 1 to 5 so that you get an idea how to solve rest questions. But you are supposed to complete question number 1 to 10 in your homework notebooks. Following are the car parking charges near a railway station up to. This is what it is given to us. This is the question. Check if the parking charges are in direct proportion to the parking time. We need to check whether the parking charges are in direct proportion to the parking time. As I told you, in case of direct proportion, x over y, that is x is the variable. Suppose I am taking time here in this question, and parking charges I am taking variable y. So you are supposed to take the ratio and find out if that ratio is constant, then we can say that they are in direct proportion. So this I am taking x and this is y. Okay, so x over y, 4 over 60. We need to solve 8 over 100. This is the second value, 8 over 100. Then 12 over 140. 24 over 180. We need to find their ratios. If these ratios are same, then we can say they are in direct proportion. If these ratios are not same, then we will say they are not in direct proportion. So let us see the solution. As we know, when x and y are in direct proportion, we can write like this. Okay, 4 over 60, I have taken the first ratio, that is 1 over 15. 8 over 100, we are getting after solving 2 over 25. 12 over 140, you will be getting 3 over 35. 24 over 180, you will be getting 2 over 15. So, we have seen that all the values, that their ratio is not same. You can compare these two values. This is not same. Previous two values are also not same. So, the parking charges are not in direct proportion to the parking times. This is how we are supposed to proceed in this question number 1. Let us talk about question number 2. Question number 2 says, a mixture of paint is prepared by mixing 1 part of red pigments with 8 parts of base. According to the table, this is the table given to us in the question. 1 part of red pigment with 8 parts of base is being mixed, and we need to find the parts of the base. You can see the blanks here that are needed to be added. So, if I will keep on increasing the parts of red pigments, the parts of base will also keep on increasing. So, this is a case of direct proportion. So, we need to find out these values. How we are supposed to proceed? As I told you that this is, suppose x I am taking and this is y. So, this will be x1, x2, x3, x4 and x5. This is y1, y2, y3, y4 and Y5. So as I told you, when the two quantities are in direct proportion, their ratio will remain the same. So what you are supposed to do, you are supposed to take the ratio, that is x1 over y1 is equal to x2 over y2. y2 is unknown. These two ratios we are supposed to take, and you will be able to get the value of y2. Likewise, you can compare this x1 over y1 with x3 over y3, or you can compare these two values also. I will be explaining it in the further slides. It will be more clear then with proper steps. Like, let the number of parts of red pigment be x, as I told you, and parts of base be y. We know that when they are in direct proportion, this is the formula which we are supposed to use. So x1 is given to us in the table, that is 1. x2 is given to us in the table 4. y1 is 8, and y2 we are supposed to find out. So taking their ratio, x1 over y1, that is 1 over 8 is equal to x2 over y2, that is 4 over y2. So we need to find y2 from this. You will be able to solve this equation, and you will be able to get this answer. So after this, what will be the value of y2? y2 will be equal to 4 into 8, that is 32. This is what I have written over here. So 32 parts of base is needed for 4 parts of red pigment. This is the first blank answer. y2 is 32. Now here what I have done, I have written everywhere x2, y2. You can write x3, y3, x4, y4, x5, y5, like I told you in the first slide. So x1 over y1 is equal to x2 over y2. Ideally it should be x3, y3, or you can write like this in this manner also. So it will be x1 is 1. I am comparing every ratio with the very first ratio, that is 1 over 8. So y1 is 8, we have written, is equal to x2, I am taking 7. y2 is unknown, so y2 will be 7 into 8, that is 56. So 56 parts of base is needed for 7 parts of red pigment. Now C part is, x2 is given to us as 12. As I told you, you can write x4 here, y4 here, or you can write in this manner also. So x1 is 1. y1 is 8, so I have written x1 over y1, that is 1 over 8, is equal to 12 over y2. So y2 will be 12 into 8, that will be 96. So this is the answer of the third blank, ideally third blank. Okay, now coming to the last blank, that is x1 over y1 is equal to x2 over y2. As I told you, I am comparing every ratio with the very first ratio, that is 1 over 8. So x1 is 1, y1 is 8, so I have written 1 over 8 is equal to 20 over y2. So 20 into 8 is 160. So 160 parts of base is needed for 20 parts of red pigment. Now this is the complete table. I have written the values after calculating, and I have completed the table. This is the final answer. So what I have, and now if you will compare these values, you will find that all these values or all these ratios will be equal to 1 over 8. Question number 3 is, in question 2 above, 1 part of red pigment requires 75 ml of base. How much red pigment should we mix with 1800 ml of base? As we have seen in question number 2, that if I keep on increasing the parts of red pigment, I will be able to get the more parts of red base. So this is a case of direct proportion, and we will be using this concept only. As the number of parts of red pigment increases, amount of base also increases in the same ratio, as we have seen. So this is a case of direct proportion, and in direct proportion we know how to solve the question. x1 over y1 is equal to x2 over y2. So this is what we have done. x1 over y1 is equal to x2 over y2. Number of parts of red pigment I have taken x, and parts of base I have taken y. So it is always better to make a table, though this is related to question number 2, so I have not made a table in this. Otherwise it is better to make a table. Okay, so x1 is 1, y1 is 75 ml. These are the parts of red base, these are the parts of red pigment. So red pigment x1 is given, that is 1 over 75 is equal to x2 is unknown to us. So, or you can make the table here also. I am showing you with the help of table. Here you can take parts of red pigment, and here you can take parts of base or quantity of base required. This is your x and this is your y. So this is 1 and this is 75 given to you, and you need to find out how much red pigment, this is unknown to us, will be needed for 1800 ml of base. So that is why I have written the ratio 1 over 75 is equal to, here I have taken x2 over 1800. So after solving you will be getting x2 as 24. So 24 parts of red pigment should be mixed with 1800 ml of base. It is better always to make a table. Likewise I have made the table here. It will be parts of red pigment, and here y I have taken parts of base. This is what I have written over here also. This is what written here also. So x2 was unknown, so we have calculated x2. Like this you can make the table and do. Question number 4 is, a machine in a soft drink factory fills 840 bottles in 6 hours. This is what I have made the table. Number of bottles I have taken x. Time in hours I have taken y. How many bottles will it fill in 5 hours? So more the number of bottles, more time will be required, more time will be needed. So this is a case of direct proportion. This is x1, y1. This is x2, y2. It is always better to make a table so that it is easy for you to understand. Now as I told you, they are in direct proportion, so we will be using this formula. x1 over y1 is equal to x2 over y2, and 840 over 6 is equal to, putting the values of x1, y1, x2 is unknown, we need to find that, and y2 is 5. So you will be getting, I hope you all know how to solve the equation. This 5 will be shifted this side, so it will be 840 into 5 divided by 6, and you will be getting x2 as 700. So 700 bottles will be filled in 5 hours. Now coming to question number 5. A photograph of a bacteria is enlarged 50,000 times and attains a length of 5 centimeter as shown in the diagram. Diagram is given in your book. You can see from there what is the actual length of the bacteria. We need to find the actual length of the bacteria. First question, we need to answer this. First. If the photograph is enlarged 20,000 times only, what would be its enlarged length? We need to find firstly the actual length. So it is given that if I do not know the actual length, so I have taken actual length as L. And that photograph is being enlarged 50,000 times. So I am taking 50,000 of this original length. And what is my final length? That is 5 centimeter. So how will I calculate L? L will be equal to this 5 divided by 50,000. This 50,000 will be shifted in the denominator on the next right hand side. Then you will be getting the actual length as this. It will be 0.0001 after cancelling out centimeter. So I hope this is clear how to find the actual length. Now if the photograph is enlarged 20,000 times only, earlier it was being enlarged 50,000 times and the length attained was 5 centimeter. Now when it is enlarged 20,000 times, we need to find how much it will be enlarged now. So let us make a table. As I told you, it is always better to make a table. So number of times photograph gets enlarged, I have taken X, and length attained, I have taken Y. When it was being enlarged 50,000 times, it attains the length of 5 centimeter. Now we need to find out when it is being enlarged 20,000 times, what will be the length attained. So this is X1, this is Y1, this is X2, and this is Y2. So Y2 is unknown here. So how can we solve it? X1 over Y1 is equal to X2 over Y2. If this quantity is decreasing, this length attained will also decrease. So this is a case of direct proportion. So X1 over y1 is equal to x2 over y2, because one quantity decrease in one quantity affects the results in the decrease in other quantity. So we have taken the case of direct proportion. So x1 over y1, we have put the values of x1 over y1, that is 50,000 over 5 is equal to 20,000 over y2. So after cancelling out, you will be able to solve. These get cancelled out, this will get cancelled out. So the value is 2. So when it will be enlarged 20,000 times, it's enlarged when the photograph is enlarged 20,000 times, it will be, and its enlarged length will be 2 centimeter. This is the answer. So I hope, dear children, you have understood the concept of direct proportion, and you are supposed to complete all the questions of this exercise 13.1. Understand, try to understand the questions, question number 1 to 5, and then on the basis of the concepts used, you will be definitely able to complete rest questions. Thank you so much.